Welcome to Debug Log, software engineering war stories, architecture decisions, and lessons learned the hard way. Let's dig in. There's this idea of a $1.30 debt tax in software architecture, and it points to a surprisingly common failure mode, when the very thing designed for speed and initial validation, the minimum viable product, becomes an unexpected load-bearing pillar of the entire system.
It's the irony of success, really. The MVP does exactly what it's supposed to do, proves market fit, gets initial users. But then, instead of being replaced or properly re-architected, it just keeps running. And every new feature, every bug fix, every integration, it costs an extra $1.30 or whatever that recurring tax happens to be.
So that $1.30 isn't just a metaphor for a small bug, is it? It's a recurring, cumulative penalty on every subsequent piece of work.
Exactly. Think of it as a hidden tariff. You're building on what the source describes as matchsticks when you needed rebar. And the problem isn't that you built on matchsticks initially. That was the whole point of the MVP. The problem is when you start stacking floors on top of them and wonder why the structure is creaking.
To unpack that matchstick metaphor a bit more, an MVP is inherently designed to be lean, often cutting corners architecturally for speed. But what is it about that initial, intentionally fragile foundation that makes it so difficult to replace once it proves successful?
Well, the core issue is that an MVP is optimized for learning and validation, not for scale, robustness, or maintainability. It's a prototype that accidentally ends up in production indefinitely. The architecture often prioritizes rapid iteration, perhaps using simpler, less scalable databases, tightly coupled components, or a single monolithic structure, precisely because you don't know if the product will even survive its first few months.
And the aha moment for many teams, it seems, is realizing that this temporary structure has somehow become permanent.
Precisely. They started with what was effectively a cardboard mock-up for a house, and then found themselves having to live in it. And every time they want to add a new room or fix a leaky faucet, they're encountering fundamental structural limitations that were never meant to carry that kind of load. The initial architectural choices, which were perfectly rational for an MVP, become severe liabilities.
So this isn't just about messy code or minor technical shortcuts then. The source distinguishes this as architectural debt, which sounds far more fundamental than typical technical debt. What's the key difference there?
It's a crucial distinction. Technical debt often refers to tactical shortcuts, maybe some unoptimized code, a missing test suite, or a quick and dirty implementation of a specific feature. These are generally localized, easier to refactor, and their impact is usually contained. You can typically address them with focused engineering sprints.
Like cleaning up a messy closet, you mean?
A good analogy. Architectural debt, on the other hand, is like finding out your house was built on a floodplain. It's a strategic misstep, a fundamental design flaw at the system level. It means the core assumptions about how the system should scale, interact, or even be deployed were either incorrect, incomplete, or simply non-existent from the outset. Fixing it isn't about refactoring a few functions. It's about replatforming, redesigning major subsystems, or even a full rewrite. It's fundamentally more expensive and disruptive.
So that $1.30 debt tax really stems from these architectural compromises, not just code quality. It's a systemic cost.
Exactly. That $1.30 isn't just the time spent on a workaround for a specific piece of code. It's the extra meetings to figure out how to integrate a new service into a fundamentally monolithic system, the hours spent debugging performance issues that stem from a database chosen for speed of development, not scalability, or the complexity of adding a new security layer to an architecture that wasn't designed with robust security in mind. It's a tax on every single future initiative because the foundation itself is inadequate.
It sounds like a death by 1,000 cuts, where each cut is small, but they bleed you dry over time. Can you elaborate on how these small, recurring costs actually manifest in day-to-day development? What does that $1.30 actually look like?
Consider a simple scenario. A product team wants to add a new type of user profile field. In a well-architected system, that might involve a quick database migration, a UI update, and some API changes, perhaps a day or two of work. But in an MVP-turned load-bearing system, you might hit roadblocks. The database schema is overly rigid and requires complex migrations that affect other parts of the system. The existing API isn't flexible enough and requires substantial, risky modifications. The front end is tightly coupled to the back end in ways that make isolated changes difficult.
So a simple task blows out into a week-long saga.
Precisely. Or integrating a new third-party service. What should be a straightforward API call now requires building custom adapters and data transformations because the internal data model is inconsistent or wasn't designed to handle external inputs gracefully. Each of these small inefficiencies, the extra steps required, that's the $1.30 tax. It adds up in developer hours, increased complexity, more bugs, and longer release cycles. It's the invisible drag coefficient on every engineering effort.
And these costs aren't always immediately obvious to non-technical stakeholders, are they? Product managers might just see a feature taking longer than expected without understanding the underlying architectural reasons.
That's a critical part of the problem. Business stakeholders naturally focus on feature velocity and market impact. They don't see the crumbling foundation. They just see a new feature taking 2 weeks instead of 2 days, and they attribute it to developer slowness or complexity, not the architectural constraints that have been accumulating for months or even years. The tax is often paid in frustration, missed opportunities, and eventually team attrition.
Which brings us to the question of why this happens. If everyone understands the importance of a solid foundation, why do so many MVPs end up carrying the weight of a full-fledged production system? Is it just a lack of foresight, or are there deeper organizational and market pressures at play?
It's rarely just one thing, but a confluence of factors. One major driver is the very success of the MVP itself. When a product finds traction, the immediate pressure is to double down, add more features, capture more market share. There's often no breathing room allocated to re-architect or stabilize the system because if it ain't broke, don't fix it becomes the prevailing mentality. The perceived risk of rebuilding something that's working outweighs the abstract future cost of architectural debt.
And the build it fast, fix it later mantra often implies there will be a later, but that later never quite arrives.
Exactly. The fix it later budget is perpetually allocated to build more now. There's also the fear of rewrites. A full rewrite is a massive undertaking, fraught with risk, potential for delays, and the challenge of feature parity. It's often seen as a black hole that consumes resources without delivering immediate new functionality. So teams opt for continuous patching and adding layers to the existing fragile structure, which ultimately exacerbates the problem.
So organizational incentives play a role here. If engineers are rewarded primarily for shipping new features and architectural improvements aren't explicitly valued or budgeted for, then the system is effectively encouraging the accumulation of this debt.
Absolutely. If the performance metrics are solely about feature delivery, then the incentives are misaligned with long-term architectural health. Architects and senior engineers might raise red flags, but if product owners or leadership aren't educated on the compounding costs of architectural debt, those warnings can be dismissed in favor of short-term gains. It's a classic case of prioritizing visible immediate progress over invisible long-term stability.
And the consequences extend beyond just monetary costs, don't they? What's the broader impact on a business when an MVP architecture becomes a permanent fixture?
Beyond the financial cost of slower development and more bugs, the impact is significant. First, there's a reduction in innovation. Teams become so bogged down by maintaining and patching the existing fragile system that they have little capacity or mental bandwidth to explore new technologies, build truly innovative features, or pivot quickly to market changes. They're stuck in reactive mode.
So it stifles agility.
Precisely. It also has a severe impact on team morale and retention. Engineers get deeply frustrated working on a system that is constantly breaking, difficult to change, and riddled with workarounds. It's demotivating to spend most of your time fighting the system rather than building new value. This often leads to burnout and high attrition rates, which then exacerbates the problem as institutional knowledge is lost.
It's a vicious cycle. The architectural debt slows development, which leads to frustration, which leads to people leaving, which makes it even harder to fix the debt.
And ultimately, it becomes a business risk. The company's ability to respond to competitive threats, adapt to new regulatory requirements, or even scale to handle increased user load is severely hampered. What started as a clever, lean way to validate an idea can morph into a strategic liability that jeopardizes the entire product or even the company's future.
So, given this rather bleak picture, what can be done? How do organizations prevent their successful MVPs from becoming architectural quicksand? The source talks about proactive planning and dedicated budgets.
The key is intentionality. Instead of letting the MVP architecture passively become permanent, organizations need to consciously plan for its evolution or replacement if it succeeds. This means having an exit strategy for the MVP, or at least a clear understanding of when its architectural limitations will necessitate a significant upgrade.
So, treating architectural work as a product itself, with its own roadmap and funding.
Exactly. The source suggests allocating a dedicated rebar budget, resources specifically earmarked for architectural improvements, refactoring, and foundational work, distinct from new feature development. This makes the investment in architectural health explicit and visible, rather than an afterthought that gets squeezed into feature sprints. It's about budgeting for robustness, not just new functionality.
And presumably this isn't about a single massive Big Bang rewrite, which often comes with its own risks.
Rarely. The more pragmatic approach involves continuous, incremental refactoring and the application of patterns like the strangler fig. This means gradually replacing parts of the legacy system with new, well-architected components, allowing the new system to strangle the old one until it can be retired. It reduces risk and maintains continuous delivery of value.
This all sounds like it requires a significant cultural shift, especially in how technical debt, particularly architectural debt, is communicated to and understood by non-technical stakeholders.
It absolutely does. Engineers need to be able to articulate the cost of architectural debt in business terms, in terms of delayed features, missed market opportunities, increased operational costs, and developer churn. Making these hidden costs visible and quantifiable is crucial for securing the necessary investment to prevent that $1.30 tax from crippling the business. It's about building a shared understanding that architectural health is a product feature in itself.
So, to summarize, the success of an MVP can inadvertently create a significant and compounding architectural debt, manifesting as a $1.30 debt tax on all future development. This architectural debt is fundamentally different from technical debt, impacting the strategic long-term viability of a system and the morale of the teams building it. Mitigating this requires proactive planning, dedicated resources for architectural improvements, and effective communication across the organization.
And ultimately, it's about recognizing that while speed is essential for validation, sustainable growth requires a solid foundation. You can build a prototype on matchsticks, but you can't build a skyscraper on them.
That leaves us with a couple of questions. How can organizations truly balance the undeniable need for speed and rapid iteration with the long-term imperative of architectural soundness? And what are the most effective ways for technical leaders to quantify and communicate the true cost of architectural debt to business stakeholders who are primarily focused on short-term market gains?
That's a wrap on this debug log. Join us next time for more engineering war stories and hard-won lessons. If any of this hit close to home, subscribe and tell your team.
Ship it carefully.